The Sun released its second X-flare in less than 3 days, and we should expect more of the same in future. On Monday, August 7, a strong solar flare caused radio and navigation signal disruptions across North America and prompted space weather forecasters to issue warnings due to energetic particles striking Earth. The flare, which was rated an X 1.5, was the 20th X-flare of the current 11-year solar cycle, which will reach its peak next year. X-flares are the strongest category of solar flares. Sunspots, which are magnetically concentrated, cool patches on the surface of the Sun, are the origin of solar flares, which are intense blasts of radiation. The photons from these flares reach our planet in 8 minutes by traveling at the speed of light. The ionosphere is the portion of the Earth's atmosphere that is located between 50 and 400 miles 80 and 650 kilometers above the surface. As the radiation from the flares interacts with these particles, it supercharges them. Radio and satellite transmissions that travel across this area are then impacted by these changes. The blackout brought on by the Monday flare, according to solar physicist Keith Strong, was a strong Category 3 on the 5-point scale created by the U.S. National Oceanic and Atmospheric Administration (NOAA). Strong stated on X, formerly Twitter, the X 1.5 flare caused an R3 strong radio blackout event on the daylit side of the Earth, most of the US and Canada, and the Pacific Ocean. The most impacted frequencies were those below 5 MHz, and navigation signals suffered. According to the UK space weather forecaster Met Office, the flare was only 2 days old when it erupted from the largest and most active sunspot group that is now visible on the Sun's disk. It also occurred just 2 days after a considerably lesser X-flare that happened on Saturday, August 5. The Sun also produced other moderate-class flares recently, 3 of which took place in the last 24 hours, in addition to these 2 intense flares. Due to the abundance of charged solar particles in Earth's atmosphere, a result of the lashing by those solar flares, the Met Office issued a warning for a minor solar radiation storm. In extreme circumstances, these charged particles may present a radiation risk to space travelers, as well as to passengers and crew on aircraft flying over polar regions. Likewise, they have the ability to harm satellites in orbit. But the current incident, which is of light type 1, ought to be rather harmless. As long as the enormous sunspot cluster is still discernible on the Sun's surface, the Met Office expects more powerful flare-ups to happen. To give space weather experts some relief, that dangerous zone should vanish beyond the Sun's edge within the next 2 days. These experts are currently preparing for the arrival of 2 coronal mass ejections (CME), which are enormous clouds of magnetized gas that frequently leave the Sun alongside solar flares. As they interact with the magnetic field of Earth, CMEs can result in a new form of phenomena called a geomagnetic storm. Beautiful aurora displays are produced by geomagnetic storms. However, because they expand the Earth's atmosphere, they can also be problematic for satellite operators. Geomagnetic storms have the potential to bring down communications and power grids in the worst-case scenarios. According to spaceweather.com, the forthcoming geomagnetic storm may intensify to a strong G3 level. On the other hand, a new computer model that combines artificial intelligence AI and NASA satellite data may serve as the tornado siren for potentially deadly storms in the heartland of the United States. The model employs artificial intelligence AI to examine data from spacecraft observations of the solar wind, or the relentless stream of material from the Sun, and forecast the location of an imminent solar storm any place on Earth with a 30-minute lead time. This might give people just enough time to get ready for major storms and avoid serious damage to power systems and other vital infrastructure. Solar material is continuously ejected into space by the Sun, both in the form of shorter, more intense bursts from solar eruptions and in a continuous flow known as the solar wind. There are occasions when this solar material causes so-called geomagnetic storms, when it interacts with Earth's magnetic environment, also known as its magnetosphere. These magnetic storms can have low to severe effects. However, in a world that is becoming more and more dependent on technology, their effects are becoming more and more disruptive. For instance, in 1989, A severe solar storm led to power blackouts that lasted 12 hours across Quebec, leaving millions of Canadians in the dark and forcing the closure of businesses and institutions. The Carrington event, the strongest solar storm on record, occurred in 1859 and caused telegraph station fires that prevented signals from being sent. If the Carrington event occurred now, it would have considerably more detrimental effects, including massive electricity outages, ongoing blackouts, and disruptions to international communications. Such technological chaos might devastate economies and jeopardize the lives and safety of people all across the planet. Likewise, as we get closer to the next solar maximum, a peak in the Sun's 11-year activity cycle, which is anticipated to occur somewhere in 2025, the chance of geomagnetic storms and their disastrous impacts on our society is rising. A global team of researchers at the Frontier Development Lab, a public-private partnership with NASA, the US Geological Survey, and the US Department of Energy, have been using artificial intelligence AI to look for connections between the solar wind and geomagnetic disruptions or perturbations that wreak havoc on our technology to help us get ready. The researchers used a technique for artificial intelligence AI known as deep learning, which teaches computers to spot patterns based on prior examples. They were able to establish connections between solar wind measurements from heliophysics missions such as ACE, WIND, IMP-8, and geotail and geomagnetic perturbations detected at ground stations all around the world by using this kind of AI. As a result, scientists created a computer model known as DAGGER, officially Deep Learning Geomagnetic Perturbation, which can quickly and precisely forecast geomagnetic disruptions around the planet 30 minutes in advance. The model, according to the team, can make predictions in less than a second, and the forecasts are updated once each minute. In order to test the model, the DAGGER team used two geomagnetic storms that occurred in August 2011 and March 2015. Each time, DAGGER was able to swiftly and precisely predict how the storm would affect various parts of the world. AI has been utilized in previous prediction models to generate local geomagnetic forecasts for particular regions on Earth. Other models that didn't incorporate AI have offered general predictions that weren't particularly accurate. DAGGER is the first to generate often updated predictions that are prompt and accurate for places all over the world by combining the quick analysis of AI with actual observations from space and across Earth. Vishal Upandran of the Inter-University Centre for Astronomy and Astrophysics in India is the lead author of a paper about the DAGGER model that was published in the journal Space Weather. With this AI, it is now possible to make rapid and accurate global predictions and informed decisions in the event of a solar storm, thereby minimizing, or even preventing, devastation to modern society, he said. The DAGGER model's computer code is open source, and Upandran claims that it could be adapted with assistance by power grid operators, satellite controllers, telecommunications corporations, and others to apply the forecasts for their particular needs. Such alerts could allow them enough time to take precautions to safeguard their assets and infrastructure from an approaching solar storm, such as temporarily shutting down vital systems or repositioning satellites to reduce damage. With the help of models like DAGGER, solar storm sirens that sound an alarm at power plants and satellite control centers around the globe may one day exist, much like the tornado sirens that ring in advance of dangerous terrestrial weather in towns and cities across America. Having said that, do you think solar flares are harmless to our health? Share your thoughts in the comments section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.